Now I want to talk about how the leading coefficient affects the shape of a parabola. So remember that a parabola is like a U-shaped graph. And so what I want to do is I actually want to graph 4 parabolas. Now these parabolas don't have anything after that leading term, so they don't have, it could be like 2x squared plus 3x plus 2, but we're going to kind of skip that other stuff for now, and we're just going to see what happens with the leading coefficient. Later on, we'll learn what all those other terms do, but for now, we're going to focus on the leading coefficient. So let's go ahead and start graphing these. You'll notice that the vertex of all of these is 0, 0, because they all don't have anything, x isn't plus something squared, and they don't have anything added at the end. So the vertex of all of them is 0, 0, and again, I'm doing that just to simplify things so we can see how that leading coefficient affects them. So let's go ahead and start graphing. So we know the vertex is 0, 0, so I'll go ahead and put that in. And then let's do -1, -2, and then +1 and +2. So actually, maybe a more sensible way to write this is in numeric order. Let's just do that for simplicity. So -2, -1, 0, 1, and 2. Okay. So x squared, so 2 squared is 4 times 2 is 8. 1 squared, -1 squared is 1 times 2 is 2. 0 squared is 0 times 0 is 0. 1 squared is 1 times 2 is 2, and 2 squared is 4 times 2 is 8. So this is going to be 1, 2, so 0, 0, 1, 2, and 2, 8. So we've got this and this. Okay. Now I'm just going to use some symmetry to try to graph this a little bit better. Try that one more time. Okay, and I'm going to go ahead and call this good enough. So these points aren't quite there, but that's all right. So let's go ahead and look at this orange one now. So keep track of the colors. So we know that the vertex is at 0, 0, so I'll just do this -2, -1, 0, 1, and 2. Again, 0, 0 we know. So let's go ahead and plug in our other points. So we have -2 squared is 4 times -3 is -12. -1 squared is 1 times -3 is -3. 1 squared is 1 times -3 is -3. 2 squared is 4 times -3 is -12. Okay, so we have 0, 0, 1, -3, and then 2 is -12, which is like all the way down there. And so let me go ahead and put that symmetry back and see if I can graph this. Try that one more time. Okay, so something like that. And sorry, it's a little wobbly, but you get the idea. So, okay. Let me actually try that one more time because it's just not looking quite right. Okay, something like that. All right, so now let's take a look at this green one. it's 1/2 x squared. So again, let's do -2, -1, 0, 1, and 2. So -2 squared is +4 times 1/2 is 2. -1 squared is 1 times 1/2 is 1/2. 0 squared is 0 times 1/2 is 0. 1 squared is 1 times 1/2 is 1/2. 2 squared is 4 times 1/2 is 2. So this is 2. Okay. Now let's go ahead and graph that one. So it's -2, 2, -1, 1/2, 0, 0, 1, 1/2, and then 2, -2. Whoops, let me get my symmetry back. Okay, so there's that one. And then finally, let's do this blue one. It's -1/3 x squared. And just for making this one easier to graph, I'm going to do -3, -1, 0, 1, and 3, and you'll see why in just a second. So if I have -3 squared, that's 9, times -1/3 is -3. -1 squared is 1, times -1/3 is -1/3. 0 squared is 0. 1 squared is 1, times -1/3 is -1/3. 3 squared is 9, times -1/3 is -3. So I did that just to make some whole numbers there. So we have -3, -3, -1, 1/3, 0, 0, 1, 1/3, and then 3, -3. Oops, let me get my symmetry back. Okay, very good. So now we want to look at these graphs and see if we can figure out how does the leading coefficient affect the shape of the parabola. So let's start by saying that 2 of these are pointing up and 2 of them are pointing down, right? 2 of them open up and 2 of them open down. So the pink and the green one open up. So these guys open up, right? And up. And these ones open down. Now I want you to take a look at these equations and see if you can see what it is that makes them open up and down. And you can think about when we were finding the values, what made it open up and what made it open down. Okay, so if you're thinking that the fact that this is negative makes it open down, then you're right. And the reason is that whenever we plugged in, whatever squared becomes positive. So when we multiply by this, if it's negative, then the whole thing becomes negative. And all of the values except for 0, 0 became negative. And that made it open down, right? Whereas if it's positive, whatever this is squared becomes positive. So then whatever you have here, if it's positive, it stays positive. So it opens up. So a negative leading coefficient makes it open down, while a positive leading coefficient makes it open up. Now I'm going to get rid of this so I can have some room to write. So a negative leading coefficient makes a parabola open down, and positive opens up. Okay, very good. So now the other thing is that you can notice here is that some of these are skinny and some of them are fat. So what makes them thinner versus wider? So let's look at the pink and the green ones next to each other. So the pink one here is skinny, right? And it's 2. And the green one is wide and it's a half. And here the orange one is thin and it's -3, or let's just not think about the negative, let's just think about the 3. So it's 3. And then this one is 1/3. So you might be noticing, so these guys are wider, right? These are wider. Oops, sorry, I'm writing off the screen here. So these ones are wider. Let me get rid of this first. Okay, so these ones are wide, and these ones are narrow. So you may be thinking that when something has a fraction, it's wide, and when it has a whole number, it's narrow. That's kind of right. The reality is that the closer this number is to 0, so ignore the negative part, but the closer the leading coefficient is to 0, let's write this nicely. So the closer the leading coefficient is to 0, is to 0, the wider the graph will be. So the wider the graph is going to be, the closer it is to 0. And you might even be able to notice that the blue one is just a little bit wider than the green one, and that's because 1/3 is a closer to 0 than a half. And here it's really hard to tell, but the pink one is actually not quite as thin as the orange one, and that's because the higher the number is, the thinner it is. So the higher the number, the larger the number, the thinner the graph is, or the narrower the graph is. Okay, so no matter what comes after the leading coefficient, this stuff is always true. The leading coefficient can tell you how narrow it is or how wide it's going to be, depending on how close it is to 0. Remember, closer to 0 is wider. A higher number, a larger number, farther away from 0 is narrower. And then that leading coefficient also always tells you if a parabola opens up or if it opens down. It opens up if it's positive, down if it's negative. Now, notice that not all parabolas are going to have a vertex at 0, 0. I just did that to make this easy for us to compare. But no matter where their vertex moves around, they still have these same features based on their leading coefficient. So the leading coefficient always tells you the same thing no matter what the vertex is. And that's how the leading coefficient affects the shape of a parabola.